So let's say we know that x equals y. Then we definitely should be able to prove that x plus 2 equals y plus 2. But do we have the axioms to do that yet, or do we need more axioms? So actually, I claim that axiom 2 is sufficient for proving this. But how? How can we use axiom 2 to prove x plus 2 equals y plus 2? So again, here's my sort of recipe format for how you apply axiom 2. You need these ingredients, and then you make sure x equals y, and axiom 2 gives you this. So for us, we need someone to play the role of x, and we'll choose x to do that, and y to play the role of y, because we're imagining a situation where we know that x equals y. Right, this is our original setup. Say we know that x equals y, and then in that context where we know x equals y, we're interested in knowing how we might prove x plus 2 equals y plus 2. Now, axiom 2 doesn't seem like it directly tells us how to do something like that. Just look here. Axiom 2 allows us to put in a proposition here, and then we can use the proposition to deduce a certain, or we can use axiom 2 to deduce a certain equivalence between two propositions. That's not the same as saying, that's not the same as an equality between two terms, which is actually what we're trying to get here. Okay, but there is a trick to make this work. Try using for the proposition. So for A, I'll just use A still. And for the proposition, I'm going to do this. A plus 2 equals x plus 2. Then what does axiom 2 say? In a context where I know x equals y, it tells me that x plus 2 equals x plus 2 if and only if y plus 2 equals x plus 2. So you see what I did to get these? I took the phi here, and on the left side, I'm replacing the a by x, so this is what I get. And then on the right side, I'm replacing the a by y, and this is what I get. So this is what I can get out of axiom 2. But look, the left-hand side is actually true by axiom 1. And so I have the right-hand side, which is actually what I wanted. Although that's not what I said I wanted, is it? I said I wanted x plus 2 equals y plus 2. So I would need to apply another symmetry there. Okay. Let me do it this way instead. Instead of a plus 2 equals x plus 2, let's base this on x plus 2 equals a plus 2, just to have a shorter argument. Then axiom 2 says x plus 2 equals x plus 2 if and only if x plus 2 equals y plus 2. And we in fact have x plus 2 equals x plus 2. So we can now formulate an argument like this. By axiom 2, x plus 2 equals x plus 2 if and only if x plus 2 equals y plus 2. By axiom 1, x plus 2 does equal x plus 2, right? Axiom 1 says that things equal themselves, and this is a thing, and so it equals itself. Thus, since I have the left side of this equivalence, x plus 2 equals y plus 2. So in this kind of roundabout way, it is possible to use axiom 2 without introducing a new axiom. It's possible to use axiom 2 to go from an equality, like this, an equality of two things, to the equality of any two terms where in one term you've just replaced one of the things by a thing that's equal to it. So knowing that x equals y tells you that any term with an x in a certain place or in some multiple places is equal to the same term but with y in those places instead. So axiom 2 does give you the power to do that, but it was kind of roundabout, right? We had to do this weird procedure where we did this and then we applied axiom 1 to the left side here. So you don't want to do that every time. You don't want to have to do that every time you want to prove something like this. And so we have done it in the notes and made it available for you to use here in Theorem 4. So Theorem 4, Axiom 2 is called equality used, and so is Theorem 4. But Theorem 4 is giving you more options and allowing you to skip some of those roundabout steps we had to take. So the first part of, so Theorem 4 has an overall assumption. If x equals y, then it's a big conjunction. 1 holds, 2 holds, 3 holds, and 4 holds. Number 1, well, that's actually just a repeat of Axiom 2, right? If x equals y, then this is true. Number 1 is just a repeat of Axiom 2. And that's just listed here for convenience so that you can go to Theorem 4 and see everything in one place. And then 2, 3, and 4 are kind of the new stuff. 3 gives you a simpler way to think about things, which is sometimes sufficient, but sometimes you need more, and you need number 1. But the main new ones that I'm focusing on right now are 2 and 4. And let me just focus on 2, since that's the powerful one. The first thing you're probably wondering about is the smiley face. So the phi here is a placeholder for a proposition. It's saying you can put any proposition in place of the phis, and this theorem will work. The smiley face is a placeholder for a term, and up till now we did not have any symbols for a placeholder for a term because we didn't need one, and basically just in this one moment we need one. So here is a temporary one that's being introduced for the sake of stating this theorem. So that's what the smiley face is. So if you look at the proof of Theorem 4 part 2, it's going to be basically the same argument that I just made, but instead of x plus 2 or y plus 2, it's using a smiley face and trying to give you a general thing that you can use. So let me show you an example of applying Theorem 4 to a particular situation. So I'm going to apply part 2 to that situation that we were just looking at. So instead of using Axiom 2 and Axiom 1 in this roundabout way, I'm going to just do this. Actually, let me go back to this list of ingredients for using Axiom 2, and I'm going to change it into a list of ingredients for using Theorem 4 part 2. And here's what it says. You need an x, you need a y, you need, well, not a proposition, but a term. You need some term. So the placeholder for that is a smiley face. So you need somebody to play the role of the smiley face. Let me get rid of these things here. And then what it tells you, so again, make sure x equals y, then you may deduce that the smiley face with a replaced by x and the smiley face with a replaced by y are equal, and these are now terms. So it makes sense to talk about equality between them. And what we were doing back there, over here, when we were going from x equals y and trying to prove x plus 2 equals y plus 2, well, that would be just applying this to a situation where x plays the role of x, y plays the role of y, a plus 2 plays the role of smiley face, and a plays the role of a. Then you can see that this says if x equals y, then you can deduce x plus 2 equals y plus 2. So you can think of Theorem 4 here as a way of adapting Axiom 2 so that it applies to terms and not just propositions. And to make things make sense, instead of logical equivalence, one has equality.